Welcome, ladies and gentlemen, to problem 7. Let's begin. Given the following, find the exact value of the 5 remaining trigonometric functions of theta. Well, we're given that the secant of theta is equal to the square root of 3. So here we're being told that the secant is positive, and at the same time the tangent is less than 0. So let's take a look at our approach. Well, first we rewrite the secant angle theta equals the square root of 3 as the square root of 3 over 1. Now, based on the introduction to the unit circle, we know that the secant is the hypotenuse over the adjacent. So in this case, from that unit circle that you were introduced to, that's r over x. So r represents our hypotenuse. So we draw a representative right triangle. So I'm going to ask you to please pause the video at this point, copy this information, and draw the representative rectangle and label it as you see it here. Now, if you do not do that, then you may as well stop looking at the video, because this will not help you. You need to copy this information. You need to copy this diagram, so that way it helps you to retain and understand what's going on. So please follow directions, pause the video, copy this information. I'm going to assume that you pause the video and copy this information. So now the hypotenuse, which is r, is equal to the square root of 3. And now x is our adjacent side, so we know that x is equal to 1. Well, there's something missing here, isn't it? What seems to be missing? I wonder what could be missing from this triangle. Do you recognize anything here? Something's missing. I wonder what that could be. Well, let's take a look. Yeah, we don't know what the opposite side is. Well, since this is a right triangle, and we know two sides of that right triangle, is there something that we can use to find the third side of a right triangle when the other two sides are known? Pause the video and let's see if you can accomplish that. Well, I know you can, but let's see you solve this. Find the value of y. There's something that we have to use in order to determine the value of y when we know two sides of a right triangle. What is that? Pause the video and work it out, then come back and let's see if you're right. Okay, I'm going to assume that you did that. Let's move on. Yes. We need to use the Pythagorean theorem to find y. Now, using our x, y, and r values, we have x squared plus y squared, because x and y represent the legs of that right triangle. R is the hypotenuse. So in this case, it's x squared plus y squared equals y squared. Well, here's what we know. We know that x is 1, so we have 1 squared. Y is what we do not know, so that's y squared. R we know is the square root of 3, so that's the square root of 3 squared. So now we end up with 1 plus y squared is equal to 3. What should be the next step? We're trying to get the y squared by itself. What should we do next? What did you say? Yes, we need to eliminate that 1. We need to subtract 1 that's here on the left side from both sides. So we need to subtract 1 from the left. So if I subtract 1 from the left side, I must do the same thing on the right. So now we have y squared is equal to 2. So now what's the opposite of squaring a number? So now we're trying to find out what y is, but we have y squared. So how are we going to find y? What's the opposite of squaring a number? What did you say? Yes, taking the square root. So here, y is equal to plus or minus the square root of 2. All right, so this is going to come in handy in a little moment. So right now, using our representative right triangle, for right now we'll let y equal to positive the square root of 2. So we have all the measurements of that representative right triangle. But now we have to determine where the secant angle theta is positive. So remember, the secant is written as r over x. So looking at this Cartesian graph, and it's broken down into quadrants, we know that the secant is positive in the first and it's positive in the fourth. So these are the two quadrants in which the secant is positive. So we have those conditions now. Right now the secant is positive because on this side along the x-axis the x values are all positive. And remember, r represents the radius of that circle, so the radius is always positive. So we have the two places where the secant is positive. Now the next condition, we need the quadrant in which the tangent is less than 0 or negative while the secant is still positive. So I wonder what quadrant that could take place in. Do you know already? Which one of these two quadrants do you think that those conditions will be fully met or satisfied? Which one do you think it is, the first or the fourth? Let's take a look. Well, we must determine where the tangent angle theta is negative along with the secant being positive. Ladies and gentlemen, it's the fourth quadrant because when we come down below the x-axis, the y values are negative. So in this case, the opposite over the adjacent will have negative over positive. So in this case, the tangent is negative in the fourth quadrant, but the secant is positive in the fourth quadrant. So now we know where to write our representative right triangle with our terminal side making an angle theta with the x-axis. So we know now that our terminal side must be in the fourth quadrant. So now our solution region is the fourth quadrant. So here we have that x is 1, r is the square root of 3, y is minus the square root of 2 because below the x-axis in the fourth quadrant y is negative. Now we can write our 6 trigonometric functions. So again, what I'm going to need you to do, pause the video, copy this diagram so you can use it to refer to as I show you the 6 trigonometric functions that are related to this diagram. So here are our 6 trigonometric functions. The sine of angle theta is minus the square root of 2 over the square root of 3. But after we rationalize this, it ends up being minus the square root of 6 over 3. Its cofunction, the cosecant, is just the reciprocal. So that's minus the square root of 3 over the square root of 2. After rationalizing it, it becomes minus the square root of 6 over 2. The cosine is 1 over the square root of 3. After rationalizing it, it becomes the square root of 3 over 3. The secant is just the reciprocal of the cosine, so that's simply the square root of 3. The tangent is minus the square root of 2 over 1, or minus the square root of 2. The cotangent, which is the reciprocal of the tangent, is negative 1 over the square root of 2. So after we rationalize it, it becomes minus the square root of 2 over 2. Ladies and gentlemen, that concludes this segment for this particular problem. Please have a very good day. This is your teacher and instructor, Mr. Joshua Davis, saying thank you for joining me. Have a fabulous day.